All right, so in this video, we're going to learn to convert from standard form to vertex form. And this is pretty useful for many ways, especially if we're trying to graph these, or if we just need to know where the vertex is, which tells us a lot of information about our quadratic. So we want to start with this form over here, and we want to end writing in this. And there's two methods to that we're going to learn about. The first one, method one, is just going to be to find the vertex, is what I'm going to call that. We'll talk about the second one on the next slide. So to do that, you just need to know really one little new piece of information. But your h, your vertex, the x-coordinate of your vertex is always equal to negative b over 2a. All right? Or opposite b, I should say, over 2a. So in this case, remember we have a, b, c. So it's going to be equal to negative 4 over 2 times 1. All right? The 4 comes from here. This is positive, so I made it opposite. A, remember, if there's nothing there, it's an invisible 1. And then your 2, well, you can use your calculator or your brain here, and that would give you h is negative 2. So we know our vertex, the x-coordinate, is going to be negative 2. This will be our vertex. I'll write it up here. All we have to do is get that y-coordinate. To do that, I'm just going to plug my x into my function. All right, so that'll look like this. F of negative 2, we learned this at the beginning of the year, and I told you it would come up and up, is negative 2 to the second power plus 4 times negative 2 plus 10. And then here, use a calculator, or let's think negative 2 to the second power is 4 plus negative 8. That's negative 4 plus 10 is 6. So f of negative 2 equals 6. So your vertex, your y-coordinate is 6. Now what you do is you just plug that into your formula, where this is h and k. So it's going to be f of x equals, let's see, a was just 1, so I don't need to worry about that. So I'm just going to put parentheses x plus 2. Remember, it's always the opposite there. To the second power plus 6. And that's it for that way. So a lot of mathy looking stuff, but really not too bad. I mean, you're just finding this, plugging it in, and then putting your vertex in where it goes, just like we did in the last problem. Let's look at the other way. And you can always choose which way you like best. And method 2 is what you learned about yesterday, and it's just doing it by completing the square. So you're going to complete the square. Because you'll notice what vertex form has in it is a perfect square binomial. So here's what we're going to do. And I like to, all right, we have f of x equals x squared plus 4x plus blank plus 10 blank. These are how I set up my blanks here, okay? F of x equals all right. Here's what I do for this. To get this term here, all I need to do, let's do it this way. I'm going to start with this term, which is just b over 2. All right? And I'm putting it under there how I'm getting it. So b is 4, so 4 divided by 2 is positive 2. And then to get here, this one, b over 2 to the second power. Okay, because this to the second power is what's going to make that a perfect square, which is plus 4. Now, if I add 4 here, to keep our equation balanced, I need to subtract 4 here. So to get my final thing, 10 minus 4 is 6. All right. So you're really kind of doing the same thing. But it's just from completing the square. You're just writing this perfect square binomial, okay? So you do 4, you divide that by in half, and then square it to get this term. And then if you add a 4, to keep your equation balanced, you must subtract the 4 over here. And then 10 minus 4 is 6. And what we'll notice is, if I write this out again, it's f of x equals x plus 2 squared plus 6. If we look back at our other one, hey, we got the same thing. That's a good sign. All right, I'm going to do one more example, and then really the best way to do these is to look at the examples, watch the videos, and practice, practice, practice. All right, so first one we're going to do by finding the vertex here. And we're using this. Remember, you have A, B, C. The only thing you have to remember for finding the vertex is that your h, your x-coordinate of your vertex, is negative b over 2a. Or, excuse me, opposite b over 2a. So in this case, 6 is negative. So it's going to be positive 6 over 2 times 1, which gives me 3. All right, so opposite. This was negative 6. It became a positive. Now to get your k, you're just going to do f of 3. All right, so all you're going to do is plug in 3 for your x, which is just your x coordinate of your vertex. Let's see, that's 9 minus 18 is negative 9 plus 12 is f of 3 equals negative 3. So your vertex is at 3, negative 3. So writing that in that form is f of x equals, a was 1, so I'll just leave that, x minus 3 to the second power, minus 3. No, that's h and k. And if you need to go back and look at your vertex form for that, you may. So let's complete the square and see if we get the same thing. So I'm going to set it up. I have f of x equals x squared minus 6x blank plus 12 blank. F of x equals x blank squared blank. All right, I always start with this bottom one. It's just going to be b over 2, which in this case, negative 6 divided by 2 is negative 3. And this is b over 2 to the second power. So negative 3 times negative 3 is plus 9. If I add 9 there, I need to subtract 9 out here. 12 minus 9 is positive 3. So we see that these match up. All right, so watch those, look at some more examples, and email me if you have questions.